Okay, so we've looked at various things over the last couple of days that affect climate. We looked at orientation to the equator, the Hadley-Farrell and polar cells. We looked at ocean currents, and yesterday we looked at the Coriolis effect. So now we're going to look at two more things that affect climate. One is Earth's geography, and the other is El Nino and La Nina. All right, so if you look at our objectives, weather and climate are affected not only by the sun's energy, but by geologic and geographic features such as mountains and ocean temperature. So we already looked a little bit at ocean temperature and how that affected California and the southeast United States. But let's look at geography. Okay, so remember that we've got energy coming right into the equator. And so it's direct energy. Because this is slanted, or the Earth is a sphere, the energy that's coming in here is spread out over a larger area. That's why it's colder. We're going to look at this in a lab that we're going to do tomorrow and Friday. But mountains and oceans can also cause a change in climate. The first one of these things that we want to talk about is the rain shadow effect. So the rain shadow effect works, it's very simple. If I've got a prevailing wind coming off the ocean and a mountain that shoots everything up into the upper atmosphere, remember that this is warm, moist air. When it goes up into the upper atmosphere, it cools, it squeezes all the water out, it rains, and when it goes over the other side of the mountain, there's no rain left, and you see deserts. If you look all along the Washington and Oregon coast, and you fly, like if you fly from Houston and you fly into Seattle, you'll see exactly this. These are the Cascade Mountains. You've got all this great, moist Pacific air coming in, going up into upper altitudes of these mountains. Rain, 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 but then on the other side is a desert. This is another interesting one. Let's look at this one in more detail. Notice that in South America, on this side, the rain is coming from this direction, but here the rain is coming from this direction. Well, how can that be? This is a great example of the rain shadow effect. So remember how our prevailing winds go. From the equator to the 30 degrees, the winds are coming this way. So if the winds are coming this way, that warm, moist air is coming here, and it's being shot up the mountains. Rain, 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 dry on this side. But once I get a little bit farther south, the winds shift. Now they're coming this direction. And so they come this direction, rain, 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 and then on the other side of the mountains is a desert. So this is just an absolutely fantastic idea. And we saw this yesterday. Remember that every 30 degrees, the winds shift in a different direction. So that's a great example of the rain shadow effect. Okay, let's look now at El Nino and La Nina. Now, El Nino and La Nina are in the news a lot because this is a phenomenon that happens in the Pacific Ocean, and it is very important, especially in the United States, to the amount of rainfall that we get. So you need to know that it's associated with changing ocean surface temperatures. This phenomenon can cause global changes to rainfall, wind, and ocean circulation. So it's super important. What I'm going to do, I think, is I'm going to show this animation now. I love this animation. This is a YouTube video, but I've turned the sound off, and I'm going to go ahead and narrate it myself so that I can kind of talk about what I want to talk about. Let's look here. Okay. All right, in the Pacific Ocean, under normal conditions, you generally have a lot of high pressure on the eastern side of the Pacific Ocean and low pressure on the western side of the Pacific Ocean. Remember that ocean waters are generally warmer on the surface than they are deep down. And so what happens is, in general, we have lots and lots of rain. So these the winds go over the warm ocean. They go up into the atmosphere, they rise, they squeeze all the water out, and they rain. And we get this kind of circular event here. And so it tends to be cooler and drier on the eastern side of the Pacific Ocean than it is on the western side. Now, when this happens and I move this water over, it causes what's called an upwelling, especially along the coast of South America. Remember that marine snow? We love those upwellings because when you have an upwelling like this, it brings fish food all along the coast of South America. And so cool water tends to hang out along the coast of the United States, west coast, and the west coast of South America, and lots of warm tropical climate and rain in the western part of the Pacific Ocean. These are what you would call normal conditions. Now, for some reason that's not entirely known, every few years these conditions shift a little bit. And so when that happens, we could get either an El Nino or La Nina event. So what we're going to do is we're going to look at what the conditions are that lead to El Nino and what the conditions are that lead to La Nina. So let's do El Nino first. What happens with El Nino, and they don't know entirely why, is that this circulation of cold to warm waters and the upwellings begins to shift. And the warm water begins to go eastward into the eastern side of the Pacific Ocean. That low shifts. So the warm water, of course, it's going to try to go from warm to cold. So it's going to warm a good majority of the Pacific Ocean. Notice that these upwellings halt. This is really important to the fishing industry in South America. They depend on those upwellings to feed fish along the coast. Literally, this can cause economic damage to them because if fish have no food, they leave, and that causes a dramatic shift in the economy of the countries along the coast. We're going to get more rain on the eastern part of the Pacific Ocean, which also affects the amount of rain that we get in the United States, and I'll talk a little bit more about that in a minute. That's El Nino. La Nina is actually an exaggeration of normal conditions. So here's our normal conditions where we have these great upwellings, lots of fish food, warm here. But in the case of La Nina, what's going to happen is that the warm conditions are actually going to shift west. We're going to get more upwellings, more cold eastern Pacific waters, and the amount of warm water is going to go down. So this is El Nino, lots of warm water pushing east. La Nina, lots of warm water pushing farther west in the Pacific Ocean. All right, so let's look at the effects of El Nino and La Nina. I'm going to stop here. All right, so for El Nino, remember, we're going to suppress those upwellings because the warm water is going to go across the Pacific Ocean, and it's going to make less productive fisheries in the South America. We have warmer winters in North America, increased precipitation and flooding in the West Coast. Remember, all that warm water, all of that rain is moving east, so we're going to get more rain on the West Coast. And drought in Asia and Australia because the warm water is moving away from them. The rain is moving away from them, so you're going to get drought. You get decreased hurricane activity in the Atlantic Ocean, and you get weakened monsoon activity in India and Southeast Asia, again, because that warm water is spread out eastward in the Pacific Ocean. La Nina is has a little bit slightly different. Remember now that our heat has gone all the way far, far west in the Pacific Ocean. So we get stronger upwelling, so that's good. We get worse tornado activity and hurricane activity in the Atlantic. Cooler, drier weather in the Americas. That makes sense because now in the Americas, we're facing a larger swath of cool water because the warmth has moved farther west. And then rainier and increased monsoons in Southeast Asia because that's where the warm water is. So, again, let's go over it one more time. This is a normal year, warm, cold, upwellings here for the fisheries in South America, all along here. El Nino, the warmth is going to move across the Pacific Ocean. It's going to be warmer than normal here, cooler than normal here. La Nina is the exact opposite. From normal, we're going to actually move more heat over to the west, and it's going to be cooler than normal in the eastern Pacific Ocean.